Lesson 8, we are finding direct variation. Now this is something that you have not done for a while, and because of that, you probably don't remember how to do this, to be honest. So this one's going to take a little bit of work today. Alright? First of all, when the statement of a problem says that A varies directly as B, or A is directly proportional to B, the equation is our bottom here. And how I look at this is when it says A varies directly. So A equals K, varies directly is the equal sign and then the K, as B. Or A is directly proportional to B, A is directly proportional to B. So there's our equation. So if we look at this, the circumference of a circle, circumference we normally use as a C, varies directly equals K times R. Now what you see in this is we see that a K is in both of those equations. K is a constant that will always be the same. You guys know that the circumference of a circle, the equation is 2 pi r. We know that we can change the circumference or we can change the radius, but this 2 pi is never going to change. It's always going to be 2 pi times whatever the radius is to give us the circumference. So our k is equal to 2 pi here. That k is not always going to be the same for every different equation, but it will be constant, it will be held the same in that equation for any situation that you have to deal with that equation for. Our next one, the resistance. So we can say R for resistance is directly proportional to the length. So R equals KL. And that's all we have to do for setting up equations. Now to actually solve problems with these, we're going to have something like this. The number of seconds varies directly as the number of minutes. So seconds varies directly with the number of minutes. Alright, so we use our first situation. When 120 seconds have passed, 2 minutes have passed. So we just plug those in. We got to solve for k here. 120 equals k times 2. And then we have to solve for k. Well, we would divide by 2 here. And as we know, there are 60 seconds in a minute, and that's what this k value stands for here. Now we would use this k value to finish our problem. And we'd use the exact same equation. So 300 seconds have passed. Our k is now 60. How many minutes have passed? So now we're solving this for m. We would divide by 60. And we would have 300 divided by 60 is 5 minutes. Do make sure you label it so that we know exactly what you're talking about. Now, with this, you might be thinking, well, I've done this before. I've done it a different way. And you have. You have done this with proportions. And you can do that absolutely when we're dealing with varies directly or varies proportionally. Alright, what we would have is we'd have 120 over 2 equals 300 over x. And now that we have two proportions, we know that we can cross multiply. So 120x equals 600. If you divide by 120, we still get that 5 minutes is our answer. Another way to solve the problem. This way, you can absolutely do with this one because it doesn't say anything about finding the constant here. If they asked you to find the constant, you would absolutely have to do it the first way up here. Okay, but if they just say answer this question, and you can set up proportions to answer the question, then do it. You're more comfortable with that way, and that way is fine. Alright, next one. When an item of clothing is on sale with a % discount, sale price varies directly as the original price. So, once again, equation S equals K times the original, that's an O there. If a shirt normally priced at $30 is on sale for 21, if I'm gonna do it this way, I would have 21 here equals K times 30. Solve my equation for K. I would get 21 over 30 is the same as 7 over 10 or 0.7. So my K value is 0.7. What is the sale price, assuming the same discount structure, of a shirt normally priced at $40? So if I put that into our equation, sale equals K is 0.7 times 40. That would give me my sale price. 0.7 times 40 is $28. Now you can absolutely do this the other way too. Alright, the numbers just get a lot bigger with this one. Alright, 30 over 21, the original over the sale, equals the original over the sale. So this would end up being, let's see, 40 times 21 is 840, I believe. No, 8,400. No, 840 equals 30 times x. And if you divide that by 30, we do end up with 28 also. So either way works here. It just depends on what the question is asking for which way you can do it. Alright, this one's a little bit different though. Alright, the speed in meters per second of an object falling from rest in a vacuum is directly proportional to the time in seconds it has been falling. Table shows the speed of an object after 2 falling times. So after 2 seconds, it's going 19.6. After 4 seconds, it's going 39.2. Figure out what the speed is after 7 seconds. Well, as we've been talking about here, these are all proportions, so why couldn't we just set up a proportion there to be able to solve this problem? So we would have 4x equals 39.2 times 7 is 274.4. Divide that by 4, we get x equals 68.6. Now we need a label on this. What are we talking about? What's our speed? Our speed is meters per second. Alright, now we need to predict the speed of the falling object after 10 seconds. So we could set up proportions here. We could go on 19.6 over the 2 seconds equals x over 10. 2x equals 196. X equals 98. And our label again here would be meters per second. Alright, so whether you do this proportionally or whether you do it with our direct variation equation does depend on you, and it depends on the equation. If it said anywhere in here, find our constant of variation, then you would have to go through our equation of, for this one, it would be speed equals k times t. And all we would do to solve for that is we would plug in our original values here. Our speed is 19.6. Our t value for this is 2. K equals 19.6 divided by 2, which is 9.8. And that would be our answer for our k value. So, and then you could use that to be able to solve for all your other things. It all depends on what you want to do with this. Any questions, please ask.